Hello, everybody, and welcome back to your channel of Math and Engineering Made Easy. In today's session, I'm not going to cover any new material. In fact, I noticed with some of the students that I tutor that sometimes when I give them a very logical problem to integrate, they take some time. They don't know how to begin, even though they have the capability, they should know it. And I will present today like maybe 3 examples, but 2 of them I noticed that cause some trouble. The third one is not causing trouble, but I want to make some remarks on it. Okay, so the first one should be pretty straightforward. I just made up some function. I want to integrate x minus 3 divided by x minus 5 dx. So that shouldn't be any problem at all, right? But how would you do it? Because I've seen most people would use substitution and say let u equals x minus 5. I want to show you that you really don't need substitution. If you compare the top and the bottom, and let's say subtract the top from the bottom or the bottom from the top, what do you see? Yes, the top is 2 more than the bottom, which means I can write it. I can rewrite this integral. I can say this becomes the integral of 1 plus 2 over x minus 5, and the problem is done. I don't need to show you how to integrate that, right? So the whole idea, I don't want to waste time if it's something as easy as, a difference between a top and a bottom is just a constant, right? The difference is 2. So it's as if you are dividing x minus 3 over x minus 5. And you say, okay, it's 1, and then you have 2 as a remainder, right? And sure enough, just to complete our work, we're going to say this is x plus 2 natural log of the absolute value of x minus 5 plus a constant. It takes exactly, since I said exactly, I don't know, 10 seconds? Okay, I know that many of you already know how to do it very quickly, but I don't want to let you waste time in a test or in a like standardized test where time is really of utmost importance. So you look at the problem, you say, oh, I know how to do that. Okay, so this one was pretty straightforward. Let's look at the second one. In fact, it was my third, but then I want to present it second. I want to integrate this ratio 2x squared minus 3x plus 5 over x minus 3. I think I need to enlarge. Let me try to enlarge that a little bit because for some reason I think it's not, the screen is not large enough. Okay, so here it is. So I don't want you to have trouble watching that. Sorry. So how would we approach a problem like that? You see that the denominator is linear and the numerator is quadratic, right? So the first thing that comes to your mind is just long division, right? That's the easiest way to do it, since I cannot factor the numerator, and even if I can factor it, it doesn't help much. So let's see. How would you do that? You just said long division. Yeah, but when the denominator is linear, you can make use of something you learn in a completely different math course, which is, yes, synthetic division. It's faster. It's faster. So I'm going to go on the side, right? 2, -3, 5. And because that's linear, The solution to the denominator is 3, so I'm going to write 3. I'm going to bring the 2 down, and 2 times 3 is 6, minus 3 is 3, times 3 is 9, plus 5 is 14. So I can say this is the integral, again, like we did last time, roughly. Notice this was a square, so that's linear. 2x plus 3 plus 14 over x minus 3 dx. Integral of 2x is x squared. Integral of 3 is 3x. Integral of this ratio is 14 natural log of x minus 3 plus a constant. Again, I know most of you know that you will divide, but I've seen students wasting time doing that with long division. Long division would be like 2 steps. This one is single line. So it saves time. And you say, oh, but we didn't learn how to. No, there is nothing you learn. You already learned how to do synthetic division in Algebra 2. So use it. Okay? Good, good. Let's move to the third type of a problem, which we already know. Suppose I have an integral like that. I've seen students who want to use, want to say, okay, I'm going to solve this using so usually they would say substitution, and that would be perfectly fine, right? But I want you to learn something after you do a lot of integrals. You should be used to do something else. I see that what's inside the parentheses is x cubed, and the derivative of x cubed is 3x squared. Even if that wasn't a 3, it doesn't matter. Suppose it was just x squared. I would say 1/3 times 3. I will create the 3. It's no big deal. So I just wrote 3, but I could have written anything else. Maybe we take another example just to complete the scenario. See how am I going to do it? Instead of using substitution. Substitution is correct, but it will take an extra step. I'm going to rewrite it. And I want you to leave me any comments if it doesn't make sense to you. I will try to explain what I'm doing, and I think everybody will see it. Sine x cubed d x cubed. What is dx cubed? Can we do that? Yeah, absolutely. You can take the integral with respect to any function of x. It doesn't have to be x. But look, when you do that, you can treat what's between the parentheses as its x. It's exactly the same. So now if I say, oh, if that was sine x dx, how do I integrate sine x? Well, the integral of sine x is negative cosine x. So equals negative cos x cubed plus a constant. And you say, I don't see that. Let me check what Mohammed is saying. I'm going to say let x cube or u, it doesn't matter, x cube equals u. So du equals 3x squared dx. So I'm going to say, okay, this is the integral. 3x squared dx is du. Sine x cubed is sine u. So the integral of sine is negative cosine u, but u is x cubed, so negative cosine x cubed plus a constant. Oh, it's the same thing. Yes, of course, that's what I told you. It's not saving a lot of time, but it gives you sometimes valuable seconds, if not more, depending on the problem. Okay, so let's take some other examples. Let's say, okay, what is the integral of 4x e to the x squared dx? Okay, I would say, well, the derivative of x squared is 2x. So I can write this as 2 because I have 4. I only need 2x. The integral of e to the x squared dx squared. You say, what is dx squared? Again, take the derivative of x squared with respect to x. What do you get? You get 2x dx. Multiplied by 4, it becomes 4x dx. So I didn't really change anything. But now, the integral of e to the x dx is e to the x. So the integral of e to the x squared dx squared is e to the x squared plus a constant. Much faster. Again, it's not hard to say let u equals x squared and du equals 2x dx, and then substitute, and then solve in y, and then bring back to x. It's a lot of steps. And you can get maybe a sign error in the middle, or you forget the 2 or something. It's much faster and much easier and to the point to do it this way. Some other people could say, well, can I use the integral of u dv equals uv minus v du, and I do it this way? Yeah, of course. And you can also use like the tabular form. It would be faster, but still, I don't think it would be faster than doing it this way. So I think that's all what I wanted to say, is that very short or like shortcuts and easy things that you may be not stressed out, but you are focused on solving the problem and trying to find a way while the answer is in front of you. It's like looking at you in the eyes and say, I'm here, just use me. Don't make it hard on yourself. Especially the first one, because I'm sad to see a lot of people taking long in a problem like that, it's just, it's a difference like 2 more. The numerator is 2 more than, so you can write it as, so again, which is the same, but, and maybe it will take more time, but just to show it to you, we can say x minus 5 plus 2 over x minus 5. So that this becomes x minus 5 over x minus 5, that's the one, plus 2 over x minus 5, which is the second one. I think everybody know all this stuff. It's just a quick reminder. It may be helpful. If it's not, then I apologize. If it is, then I'm glad it helped. Thank you very much for your time. Hope to see you soon. Have a great day. Bye.